Hello, today I'm going to introduce a hash encryption algorithm called bcrypt, and it's also a usable JavaScript module that can be used in our project. The basic idea of bcrypt is to use a random generated thought combining with original password executed by a hash function for multiple rounds and generate a hash strings, and the generated hash string will be stored together with the thought in the database. Here is an example of the generated string. The first part, separated by dollar symbols, is the bcrypt flag. That means this string is generated by bcrypt algorithm. The second part in blue color is the number of rounds that is executed. This information is required when you need to validate the password. And the next part is the thought, randomly generated based on the password. The thought is randomly generated. That means even the same password can have different thought in different times. So the left of the string is the hash string itself. The bcrypt algorithm has two advantages. Firstly, it takes long time for single calculation. For example, a simple traditional MD5 function will only spend like 1 microsecond on generating a hash string. Then, in the case of bcrypt algorithm, it will cost like 1 second to generate a single hash string. This will help us protect our password from decryption better. I will explain why later. And the thought is randomly generated and stored together with the hash value. How do you decrypt a hash algorithm? Let's take the MD5 algorithm for example. A hash function is a unidirectional function that receives a string as its input and output a string of given length. Here the input is m, and after it's processed by the function, it generates a string of 32 digits. Theoretically, this function is irreversible, but the intruders still have methods that can guess the original passwords. For example, we know that many people use birthdays as their password. The commonly used birthday, it will have like a range of 80 years from now to like 1940, and there were 365 days in a year, so the possible result of birthdays will be 80 times 365. The hacker can try to use the MD5 function to calculate the hash strings of all these possible birthdays. Then he will get 80 times 365 types of hash strings. And now he has gotten a string from a database that is encrypted by MD5. He can search it in the outputs generated previously to see that if any one of it can match the string he just got from the database. If there is a match, that means the corresponding original password is the password he wants. And there are two advanced methods of decryption. One is called pre-computed hash strings and one is called rainbow table. They are pretty much the advanced version of the method I told before, just that they are using the space to chase for the time, so they will be faster. Why is Bcrypt better than traditional MD5 plus salt? Assuming that you're using a salt for all the passwords in your database and store the salt in your code, if a hacker has the opportunity to get the data from your database, possibly he can also get the salt from your code. So if the salt is acquired by the hacker, then it's totally meaningless, because the hacker can extract the salt from the password. So we need to assume that the intruder can get the salt but still unable to decrypt the password. If a hacker need to use a rainbow table to decrypt the password, then the Bcrypt algorithm will be much better than MD5. For example, MD5 will, for each row of the rainbow table, the MD5 will only spend 1 microsecond. That means generate a rainbow table with millions of lines will only take hours by a powerful computer. But in the case of Bcrypt, each line of the rainbow table will cost like 1 second. That means a rainbow table of millions of lines will be generated after years, literally. So in practical thing, Bcrypt algorithm is pretty much impossible to decrypt, because it will take a really long time to generate a rainbow table for it. This is why Bcrypt is safe, and let's see how it is implemented in the real application. Here is the Health Manager web application I developed before, and let's try to log in. Let's try to log in and see how it is validated. Here you can see that in the code I passed the username only to the backend without pass the password on the internet, so that it's impossible to acquire the original password from the internet. And the backend returns us with the result object. Here is the hash string of the password of the user test, and let's see whether this hash string will match the password I input. This bcrypt.compareSync can compare the password and the encrypted password. Obviously, I succeeded to log in. Again, let's try to register a new account like test2. Let's see. Firstly, I need to designate the number of rounds we are going to execute hash function on the password. Here I designated by 10. The salt randomly generated is showed here, and here is our original password. Let's see, the content is test2, and we will need the test2 and the salt generated as parameters to generate the hash string here. Here is the complete generated hash string that is going to be stored in our database. Here I'm going to post the generated password to our database. Let's see in the backend what will we have. Yeah, as you can see in the backend in our database, there is only the encrypted form of the original password so that nobody can decrypt it in an acceptable time. Here is the usage of bcrypt algorithm. Thank you.